Hey guys, David here and welcome to another Dark Art Guitars video. Today is finally the final big video of this Dark Art CNC. It's been a journey, it's been about 6 months of me building it, and you have probably seen quite a few of the videos already. Now in this video I want to give you a general overview over the entire machine, all its different specs, its feeds and speeds, what it can do. I will also briefly go into all the different components. Then I will also talk about what kind of improvements that I can do, what I like about this machine, what would I do differently next time. And finally, I will also be talking about the price, the cost of this machine. What did it really cost me to build it? I know a bunch of you guys have been curious about that, so there will be an answer towards the end of this video. Now another thing I've been commonly asked about is the 3D model for this machine, which I did in Fusion 360, and yes, it will be available as this video goes live now. It should be available for sale on my website. Now it is just the model of the machine itself. It is not a step-by-step guide on how to build this machine, nor is it a detailed set of plans with instructions. I will have a separate video. I'm not sure if it will be public or unlisted, but I'll have it linked below this video, and it'll also be on the product page as well, that goes in depth about what is included in the model and what not. And just like my other digital downloads, for the first week after this video goes live, it will be 50% off, and after that it's just going to be regular price. Now starting with the general overview, I'm actually going to take my notebook here so that I get all of the numbers correct here. The working area of this machine as it is done now is 1230 millimeters on the y-axis, 200 millimeters on the z-axis in travel, and 666 millimeters on the x-axis. Now, as much as I love to claim credit for getting it exactly to that number, I was actually aiming for slightly higher, but with all the bellows and everything, that ended up being the number that I can comfortably reach. So, well, that's what the travels are now, and I can't say I'm mad. The gantry clearance between the spoilboard and kind of the lowest part of the gantry is 150 millimeters, so that's the tallest object I can machine. And by having 200 millimeters of actual Z-travel, that means that I can get the tools comfortably out of the way, and I can also machine the spoilboard. For example, like all these holes in here, I can drill in situ. And if I ever upgrade to something more fancy, like an aluminum base plate here, I can also cut the threads and everything in that directly with the spindle. So it can reach low enough and it can get high enough to be out of the way. The rapids on this machine are 16,000 millimeters per second. That is mainly limited also by the Masso Controller. I could probably push it to 20,000 if I really wanted to, but 16,000 is already scary fast, so I'm perfectly happy with that. In terms of cutting speeds, realistic maximum cutting speeds are around 6,000 to 7,000 millimeters minutes, and most cuts I run at like 5,000 to 6,000 millimeters a minute. That is also quite fast. On my Killer Bee, I was running more into like 3,000, maximum 4,000 millimeters a minute, so that is quite a bit of an improvement. The total weight of this machine is around 220 kilograms, or like 450, maybe a bit more pounds. Now this is not actually me weighing the machine, this is just what Fusion spits out for the model. Seems a bit on the high side, but it shouldn't be that far off. Just to kind of give a bit of a reference. So with these basic specs out of the way, let's go a bit deeper into the different aspects of it. And I think we can start from basically the bottom up. So the base frame of this machine is made out of 40 series aluminum extrusion, as I've already mentioned. I sourced that from Rutwick. They gave me a small discount, but I paid for it for the most part. And we have the 4 high on the sides, so 160 millimeters, and then the kind of cross beams underneath the spoilboard are 80 millimeters. For the gantry here, I have 2 horizontal 80 millimeter and a vertical 120 millimeter. So in total, we have 200 millimeters in height in the extrusions. Then I just have a couple other just 40-40 and 40-80 in various other spots for kind of things. And in the front, I also have another 120 millimeter as an additional front plate where I can machine stuff from the front. For the linear motion, I have HT25 linear rails on the Y and the X axis, and HT15 on the Z axis. They are Hewin linear rails, but not bought directly from Hewin, but through some AliExpress sellers, so they're probably kind of out the back door. They didn't come with any certificates, but were also a lot cheaper. However, the rails themselves do look genuine. All the markings look genuine, and they feel like high quality. I do not have the equipment to measure if they are maybe they barely didn't pass the accuracy tests of Hewin, for example, and that's why they are sold out of the back door for cheaper, or what exactly the deal is. They are linked down below, but buy them at your own risk. For the lead screws, I'm using a 1610 ball screws, so a 10mm pitch, 60mm diameter, and they are C5 grade from AliExpress. So they're kind of, you have your C7 and your C5. Your C7 is the kind of more generic and technically not actually meant for precise movement, just for motion. Most kind of cheap builds will use C7, that's what's mainly available, but these C5 were not that expensive. They're also not some sort of name brand, so I once again don't have the technology to measure their accuracy, but it should be a bit higher quality than just the cheapest C7 pair out there. For the Z-axis, I'm using a 1204 ball screw, and that one actually sadly is not available in C5 grade, so it is a C7 grade. And actually, the one I originally had in here ended up blowing up on me. The balls inside of the ball dot cracked. It started making horrible sound, so I had to replace it, and I replaced it with one from Sorotech in Germany. Also a fairly inexpensive ball screw, but it was just a lot quicker to get it shipped here. I think part of the issue was I didn't quite have and not aligned perfectly. That's why there was more load on it, but also the quality of the one I bought in the first place was really poor. So try to buy not the cheapest one at all, if at all possible. Then moving on to the servo motors that are driving this and making these insane speeds possible. And those are the Leadshine 400 watt servo motors with the EL6 servo drives. And they were courteously provided to me by Leadshine free of charge for making the video. So big thank you to Leadshine once again for sending those over and making this project possible. I could not be happier at all with these servos, and at first I was a bit worried about if I maybe got too small of a servo when I saw them. They are smaller in size than the NEMA 23 motors that I had on my Killer Bee. However, their power does not disappoint. I am not saturating the power limit whatsoever. You can see the load of it on the servo drives, and these have scary power. Anything bigger would definitely be overkill for this machine. Not only can they accelerate this gantry kind of fast enough to make the whole table shake, I personally cannot make the table shake. It feels rock solid to me, but when this machine gets going, the table shakes. I also actually used, because I could not move the table anymore, I just put some blocks of wood behind the y-axis and used the machine to push the whole table forward a couple of centimeters when I had to move it a bit forward. And the servos barely even broke a sweat. So they are scary powerful, and I really need to watch out not to have any limbs where they do not belong, because the machine will be more powerful. It is also definitely powerful enough to self-destruct. So it is a machine that requires some respect, and there has definitely been some poker factor already in the past. But that is not a fault of the servos, that is great actually, and that's what we want to see here. We do not want to have the servo motors as the limiting factor. Since I last talked to you in the servo video, I have also tuned the y-axis servos. It is kind of a hacky workaround. I took the z-axis off of it and disconnected one of the sides, and then I just tuned one of the servos and then applied that same tuning to the other side. And by having the z-axis removed, the weight of the gantry should be lower enough that it roughly matches up. Ideally, there would still be a way to kind of tune them together, but with the EL6 drives, that is sadly not possible. As a reference for homing, I have inductive limit switches on all the 4 axes, and they are just on one side, so I'm relying on soft limits for the other side. And they work great so far. They're fairly generic ones, and they just hold on a couple of bolts here on the X and Y axis and a little play on the Z axis, and works great, no complaints there. Moving up slightly, the beautiful black parts that you can see here that cover the kind of extrusions here, as well as some of the linear motion components, and keep the dust away. These were generously provided by PCBWay. They are 2mm aluminum, sheet aluminum that has been cut out, bent by them, and then powder coated in black. It is a super durable coating, looks super professional, and I'm super great. And I'm very grateful for PCBWay to provide these. You can go check out PCBWay's services, linked down below. They can do sheet metal like this, they can do CNC machining, 3D printing, and of course PCBs, as the name implies. I really am happy working with them and can highly recommend. Then in between these PCBWay covers, we have the Spoilboard, and this is a somewhat temporary solution. I do not really know yet what my final kind of end-game CNC surface looks like. There's a lot of different options, and right now I don't really love any of them. So I decided to just go with MDF sheet for now, as that is nice and inexpensive. I drilled a grid of 50mm spaced locating bores in here. They are 8mm, and this allows me to use dowels, locating dowels. They are also perfectly aligned to kind of the machine coordinate system, so I can use it to flip over stuff and locate it again. For example, if I'm machining both sides of a guitar body, I can use these holes and drill some matching holes in the blank from the top side, and then I can just use the coordinate system from these holes and don't even have to probe anything in, and it just lines up perfectly. That works really nicely, and that feature of these holes I'm definitely keeping. I've also now added some threaded inserts in from the back. These are M6 threaded inserts, and adding these over 200 inserts took exactly as long as you would imagine and was exactly as painful, but this should allow me now to be able to screw stuff down to it more easily as well. Used some wood screws before, but that just kind of doesn't hold that well and really mars up the Spoilboard, so this way it should last a bit longer. My goal is also to build some fixtures that will locate on these bores and then be screwed down with these M6 bolts. But then in the long term, I'll probably move to either an like plastic, like Delrin Spoilboard, or even a full aluminum one. But I have to first kind of fully decide on what I want to lay out, how I want the holes for threaded inserts, all of that, as a Spoilboard like that costs a lot of money, so I want to have it first time right. But you can also see back here in nice shiny aluminum is a fixture plate from Saunders Machine Works. This allows me to use their mod vices, and it's just a really super low profile, convenient way of holding kind of smaller parts, mainly for metalworking. So once I get into making my own hardware, I will be using that mainly, and I can clamp it in there. I can make soft jaws and hold small metal parts much more easily than I could on like a wooden Spoilboard. For now, I have not used that feature. I also have not used the vertical clamping surface yet in the front, but over the coming year, I hope to make more use of that. Then the heart piece of this machine here is my Spinogy X22 SK20 ATC spindle. It's the air-cooled version, and I am absolutely in love with this spindle. Now, it was quite the investment. Big thanks to Spinogy for providing me with a hefty discount on it. However, it still cost me about as much as my entire Killer Bee setup cost me to get this spindle in here, but it's definitely worth it. This is such a massive upgrade to the spindle I had on my Killer Bee that it doesn't even warrant a fair comparison anymore. It also is just 2.2 kilowatts, so the same nominal power as my previous spindle. But not only does this one do 30,000 RPM by default, it can do 30,000 RPM 24/7 without overheating. It barely gets warm to the touch, and it's super precise. It also is a lot more quiet. Now, at 30,000 RPM, you do kind of hear it scream, but it's still more quiet than my cheap Chinese one was at like 18,000 RPM. Also, these SK20 tool holders, well, the name brand ones from Spinogy do cost an arm and a leg, and especially getting 10 of them, they are super high quality. They locate very precisely with the Rigafix collets in there, and by combining this with a low runout on the spindle, I can get much better tool life. And having 10 pockets here with 10 tool holders, I can use the right tool for the right job, and kind of have it automatically change. This spindle is a perfect match for this machine. The machine kind of provides the more rigid backbone that I can drive the tools faster and harder, but without a reliable spindle like this, that still wouldn't do me much. Thanks to the kind of higher RPMs that I can get for the small tools, combined with the kind of just more power from the more solid machine, I see a decrease in cycle time of like 30 to 50% or even more, depending on the operation compared to my Killer Bee setup. And that does not factor in any of the tool changes at all. If I do factor in the tool changes, then they're probably more like 4 or 5 times speed increase because of how much I can get done in a day. So if you are looking for a super high quality, made in Germany, reliable spindle, do check out Spinogy's lineup. They have a very vast range, and you can actually see that this spindle is kind of built up in many sections. And you have just the base spindle, which you can get with just a manual tool changer. Those are fairly affordable. And then you could add an automatic tool changer on there. You can have in air-cooled, water-cooled versions, different tool holders. And they now also have their X30 kind of more powerful machines if you're looking for even more power. And I here have the 4-pole motor winding, which means that at the lower speeds they do get more torque. You can get a bunch of different windings. You can also get these in super high spindle speeds. If you work with a lot of tiny tools, you can get it with like over 40,000 RPM spindle speed. The options are limitless. But I think for my application, my choice was correct, and I am very happy to be working with them. Then one thing in connection to the automatic tool changer, I of course also have a tool setter here. This is just a fairly cheap tool setter. It has kind of 2 switches internally, so one that is actually setting the tools that activates basically as soon as it touches, and another one further down that is just kind of a safety one that is wired as an e-stop. And that allows me to touch off all of my tools. Now, with the face build, I can have to kind of jog it a bit to the side, as of course the touch off point is quite small, but all the other tools touch off automatically perfectly fine. And then once I put a tool in the tool holder, I touch it off right away. And then during the program, actually the tool setter is not used at all. So I only ever use the tool setter while I'm actively there looking at it. That's why I also do not have the air blast for it hooked up, as I can just manually make sure that there's no chips on it. Now for the pneumatics, to activate the automatic tool changer as well as for the air blast, I have a couple of solenoid valves here in the back as well as some regulators. I was able to get a good deal on some used Festo brand solenoids, so it's really nice to kind of have like name brand high quality solenoids. They cost me less than the cheap AliExpress ones, and will definitely last me a lot longer than one of the bottom barrel ones. So maybe if you are looking for some pneumatic stuff as well, do check like local marketplaces. Sometimes industrial surplus these get decommissioned. However, like one solenoid valve tends to last a long time, so even if it already has some years on it, there's a good chance it will still last you a lot longer than a cheap knockoff. Then to connect all of this circuits, I have here the Masso G3 Touch, which was provided to me by Masso for the kind of this CNC and these videos here. I also have the jog pendant from Masso to go along with it. And if you have not seen my video on this controller and how I integrate it with my CNC here, do check it out. YouTube somehow did not really serve that out, so it has very low views. Like by far the least views out of any of the videos of this series. So I'll have it linked in the series, of course, as well. So if you missed that because you didn't show it, you make sure to go check it out. It's go really in depth looking at how this controller can help me with my machine, and I'm really happy with it. It's, in my opinion, a great value, offering the touchscreen and everything in an all-in-one, like not having a separate computer attached to it, and it works great. It's not the cheapest controller, but for me, kind of the trade-offs are worth it. For more details, once again, you can go check out the video on it. And with that, I think we have concluded the general overview, and some of the things I've already mentioned that I did since the last video, mainly the like upgrading the spoilboard. I added some little descriptions here. I also hooked up these 3 lights here as kind of indicator lights, so like the tower lights you see on top of a machine. So that is hooked up. Now the outputs from the Masso, although the Masso runs on 24 volts, are only 5 volts, so I have to use a little MOSFET to get those controlled. But those are working now. Of course, well, if I press the E-stop, for example, here, we can see that the error light is blinking, and some of that. Now, a couple of things that I still kind of want to address is the dust shoe. I've mentioned it in my video about it, that the plexiglass kind of got slightly warped, and so the magnets don't properly align. And I've had it once or twice actually fall off during a manual tool change, which is not good at all. That's why there's tape here now to make sure that it doesn't do that anymore. So I will be remaking that. I ordered more acrylic, and maybe I'll integrate an additional like mechanical fastening in addition to the magnets, just to be on the safe side. But well, I'll keep you updated in some future video or on my social medias about that. Then the only other kind of things that I would have loved to do differently, or like would do differently next time around, one of them is this cover here in the back. I just made it this tall to like kind of line up with everything and look nice, and it makes it easier to produce. However, the dust shoe kind of sort of collides with it and just kind of pushes the bristles up a lot, and there's no reason for this to be quite this high. This could easily go down one level, so 40 millimeters, which would allow to clear the dust shoe perfectly, and all of the internals would also support that. So I have already updated that in the 3D model, so if you get that, you will have both options available. So if I were to do it again, I would get a different cover, but it's not really worth it to get a whole new cover just for that. It still works like this, it just kind of squishes the dust shoe a bit more than I would like. Another thing that I noticed is these just big hollow extrusions, especially on the x-axis, do have some sort of like resonance ringing going on. If I move the x-axis back and forth, you can really hear them kind of singing and ringing back there. So maybe just filling these extrusions with some epoxy granite. Now they don't have a very big internal cutout since they're just single width. But even that little bit could already help, or having a slightly different structure would kind of reduce those vibrations and kind of dampen the whole machine a bit more, and that would probably result in slightly cleaner cuts, especially when I get more into metal cutting, where a surface finish is a bit more visible than in wood. I could imagine that there you could definitely see a difference. Now, the reason why I went with aluminum extrusions is it is very easy to build, and I would probably go with that same solution again and just maybe fill them with epoxy granite or something. By the way, just sand will not help. You need to kind of solidify it with epoxy or something. But a different approach would be to use like sheet metal back here, or like a thick steel plate that would also already have a lot more damping than these hollow aluminum extrusions. Another kind of more simple approach could be bolting a big steel sheet to the back of it with maybe a rubber damper in between. That would also probably cut down on the vibrations a bit. All things that I might explore in the future, but it's not very urgent at the moment. Also, if I would do this whole thing again from scratch, I've mentioned it in the dust shoe video, I would probably not bother with the electronically controlled one. Instead of having a stepper motor here with a lead screw, I would just have a pneumatic activated cylinder. Since I have pressured air already, anyhow, that will be very easy to integrate as well. And then I can just have an adjustable end stop that kind of sets my Z height. And that way I can still set the perfect dust shoe height for every operation, but it's just a lot easier to integrate, less moving parts, less things to go wrong, and would also integrate better with the controller as well. But since I already have it, it does work. I'm not going to change that. But if you're building your own machine, maybe don't go for this overcomplicated version. The only other thing I might do differently is add some more kind of dust protection here for the Z-axis. Maybe add just like 3 centimeters to the Z-axis on the top. That wouldn't really decrease the rigidity of anything. Make the machine slightly taller, but that wouldn't matter. And what this would allow me is to have at least accordion bellows here at the top, just like I have here on the x-axis. Would still be exposed on the bottom, and the dust shoe rails are still exposed, but that would already be a bit better. Now, ideally, I would come up with a system that encloses everything here but it's not easy to engineer that. And for kind of my just first attempt at building that from scratch, I was pretty happy with it. And in general, I was very surprised. These couple of minor issues that are more minor annoyances than deal breakers have been the only things wrong. Everything went together how I intended to. Was just minor persuasion. I didn't really have to remachine any of my big aluminum parts, although I machined them like on my old machine before I had everything else that has fitted with. So that just goes to show that somehow I got lucky in my 3D model and stuff actually matched up in reality, which if you're just kind of a hobby mechanical engineer is quite the achievement, so I'm very happy about that. And now I think we're far enough into the video that I can finally address the big question a bunch of you had. If you just skipped here, shame on you. You should watch the whole video, it's really interesting, but all joking aside, that doesn't matter. I am going to talk about the cost breakdown of this machine. Now, I did have a lot of sponsors on this build. You also heard it in this video, and I'm super grateful for these sponsors. I could not have built this machine in this current state without all of these sponsors. So the prices I'm going to list here now are kind of for the retail cost of these components, as that is what will be applicable to you. I'm also going to list them in Swiss francs, including shipping here to Switzerland. As for like all of the small parts, like from AliExpress, that kind of factors into the price a lot. And I'll convert the end price to US dollars for you as well, but otherwise it's roughly 1.1, maybe 1.15 Swiss francs to US dollars. So just something to keep in mind. Now, I also want to preface this section here is that this is not me trying to brag about how fancy and expensive a machine I have. And by no means do you need to spend that much money on a CNC machine. You can build a very, very capable machine for a lot less. But this has kind of been my dream machine. I've worked up to it, and I sold my Killer Bee as well as my BF30 CNC that I was working on before, and that together with all the sponsors was able to finance this project here. So with that, let's just go down the list of the different components. So the raw aluminum for the plates here, I got locally here in Switzerland from the Metal Service. That is only really applicable if you live in Switzerland. And they were very easy to work with. They're a big shop, but you can just order the stuff. You need to buy enough quantity of one single size. So all of the different plates here, I actually got like unit sized, and I just cut them up and to the exact shape myself. And for like the thinner plates, like the motor mounts, I ended up getting a bunch of extra ones because buying 8 of them was the same price as buying 1. But for all of that, including the spares that I still have now, I paid around 500 Swiss francs for the raw aluminum. For the aluminum extrusions from Roderick, those are around 700 Swiss francs, including shipping. And that also includes a couple of small hardware things that I got from them, but most of the hardware I got separately. All of the mechanics, so the linear rails, the ball screws, for all of the axes together from AliExpress, I paid 1,500 for those. One thing that really kind of surprised me of just how much that added up is all the hardware. So all of the nuts and bolts and T-nuts and little things like that. And that was at least 300 bucks. Those is kind of spread across a bunch of orders, so I don't have an exact number on that, but that was definitely surprised. Just going to the hardware store, buying a bunch of bolts for it, and check out being 100 bucks just for bolts, that definitely surprised me. The Leadshine servo motors, I actually don't know the exact price for them, as you would have to request a quote from them, but it should be somewhere in the neighborhood of 1,400 for the 4 axes, including the servo drives. The Masso, including a jog pendant, is also around 1,400. Once again, I did not pay for that myself. All of the electronics, this big electronics cabinet I also got used for a really good price, and it included like some power supplies, some breakers, some relays in it already, so I got a really good deal on that. And that together with all the wires and other like random electronics things I had to buy was around 400 Swiss francs as well. Then these sheet aluminum parts here from PCBWay were also actually quite expensive. though a large portion of that is just that they are very large and awkward to ship, so they had to build a custom crate for it, and the shipping, so like the crate and shipping and everything was probably more than half of the cost, but they were $900. I could probably get them for almost the same price locally, just because the shipping does not come into effect, but otherwise, like, the actual price for the sheet metal parts from PCBWay is really good. So if you have some slightly smaller parts, their price is absolutely unbeatable. Then there was probably another like $300-400 for just random miscellaneous stuff that I did not attribute to any category here. I have a whole bunch of different AliExpress orders that kind of got all mangled together. Then the last item here, the Spinogy Spindle, plus all of the tool holders and collets, as well as the VFD and the line filter, all of that together was around 7,000 francs retail. That is definitely a hefty sum of money, but I think it's worth it for like the quality that you get here. So all of that added up is 14,400 Swiss francs. That amounts to roughly $16,000 US. Now, what I actually paid for that is just a bit over half of that price, thanks to all of the different things that I was able to get from the sponsors. Now, if you're looking at this machine and you want to build something similar, but this price just shocked you a little bit, some things where you could save quite a bit of money, get a very comparable machine is, as much as I love my Spinogy Spindle, if you went with a Chinese automatic tool changer spindle, you might have to put in a bit more work, and it might not be quite as reliable and precise, but you could easily save like 4,000 to 5,000 francs there. And also by going with closed loop stepper motors instead of Leadshine servos, you could save another couple hundred there and still have mechanically basically the same machine. And with those savings, you could probably get it around 10,000 USD for a machine that is quite similar, if not exactly the same. Now, although I'm calling this project done for now, no CNC DIY project is ever done, and I will definitely be continuing to work on it. I will continue working on kind of some fixturing and more things on like the Spoilboard side of things. I'm going to have another video on that. I don't know when that is going to be, not very soon, as I can just kind of work on that in the background. I will also make a separate video about kind of the feeds and speeds I can get with this machine. I will combine that with kind of a Fusion Cam for guitars tutorial. So there I'll just go through the machining strategy for one of my guitars, including all of the feeds and speeds for this machine and machining it live as well. That should come out within the next couple of months as well, and kind of give you a bit more of a glimpse into what this machine can actively do. I'll also, of course, have many more guitar builds where this machine will be featured, at least in the background. But if there are any other kind of specific things that you would like to see more about this machine, do leave a comment down below, and maybe I'll make a video about it in the future. And with that, a big thank you guys for watching this video, for following along my progress here with this machine, and I hope to see you again on this channel, and you don't leave just because this project is done. So with that, thank you guys for watching, and I'll see you next time.